here's something that's going to blow your mind. In a recent study with over 100 expert NLP researchers, something unprecedented happened. The researchers were asked to generate novel research ideas, and then those ideas were evaluated in a blind review process. The twist? Half the ideas weren't generated by the human experts at all. They were generated by an AI. And here's the kicker. The AI-generated ideas were judged as statistically significantly more novel than the human-generated ones. We're talking p less than 0.05 significance here. The machines didn't just match human creativity, they exceeded it.
But let me paint an even more vivid picture of what this means. Imagine Dr. Sarah Chen, a postdoc at Stanford, spending 3 weeks crafting a research proposal on neural architecture optimization. Her AI counterpart generates a comparable proposal in 3 minutes. Not only is the AI's proposal judged as more novel by peer reviewers, but it identifies cross-disciplinary connections that Sarah, despite her PhD and years of experience, simply missed.
This isn't science fiction. This happened in 2024, and it's happening again right now as you listen to this.
Welcome to Mindcast. I'm your host, Will, and today we're diving deep into one of the most profound questions of our time. Are large language models truly a moonshot in human research capability? Not just a fancy new tool, but an actual paradigm shift that fundamentally changes how we discover, synthesize, and create knowledge. By the end of today's episode, you'll understand what makes a true moonshot versus just incremental progress, why our old research system was fundamentally broken, and most importantly, what this all means for humanity's relationship with knowledge itself. We're going to explore some uncomfortable truths, some amazing possibilities, and I'll give you 3 concrete takeaways about how to think about this technology that's reshaping everything. Let's start with a critical question. What actually constitutes a moonshot? Because this term gets thrown around a lot in Silicon Valley, but most people using it have no idea what they're talking about. The original moonshot, JFK's 1962 declaration that America would land a man on the moon, wasn't just ambitious. It had specific characteristics that we need to understand. First, it tackled a huge problem. Second, it proposed a radical solution. Not an incremental improvement, but a complete departure from existing approaches. Third, it required breakthrough technology. And fourth, this is crucial. It aimed for a 10 times improvement, not 10%. We're talking 1,000% better, not marginally better. Now, to understand why LLMs might qualify as a moonshot, we need to look at the broken system they're replacing. I call it the gated paradigm, and folks, it was deeply, fundamentally flawed. Think about how research actually worked before this moment. You had human intermediaries everywhere, librarians who controlled access to knowledge, conference gatekeepers deciding who could present, publishers creating bottlenecks that took months or years to navigate.
But here's what's fascinating, and this gets to something really profound about serendipity. The old system was slow and inefficient, yes, but in that friction, something magical happened. When you had to physically walk through library stacks, when you had to sit through unrelated conference sessions, you stumbled upon unexpected connections. Fleming discovered penicillin by accident. How many breakthroughs came from researchers wandering into the wrong section of a library?
Let me give you a concrete example of just how broken this system was. In 2019, an economics researcher at MIT needed to analyze patterns in 500,000 corporate earnings reports spanning 20 years. The traditional approach would have required a team of graduate students, months of manual coding, and access to expensive databases that cost thousands per month. The total project cost?
easily $200,000 and 8 months of work. But here's where it gets really absurd. After all that work, the researcher would still face what I call the synthesis bottleneck. Human cognitive limits mean that even the most brilliant researcher can only hold maybe 7 to 9 concepts in working memory at once. So after processing 500,000 documents, the actual synthesis, the moment where insights emerge, was still constrained by our biological hardware. And this wasn't unique to economics. Medical researchers faced the same problem. There are over 30,000 new biomedical papers published every month. A cardiologist studying heart disease treatment couldn't possibly keep up with relevant research in immunology, genetics, material science, and artificial intelligence, all of which might contain the key insight for their breakthrough. The old system didn't just slow us down, it artificially fragmented human knowledge into silos that prevented the kind of cross-pollination that drives real innovation. This creates a paradox that we need to grapple with. If LLMs optimize for efficiency and instant answers, do they risk eliminating the very friction that enabled divergent cross-disciplinary discoveries? It's a question that cuts to the heart of how creativity and innovation actually work. But let's get to the evidence that this really is a moonshot. We're talking about quantifiable leaps that are almost hard to believe. In one 2024 study, researchers looked at data collection from corporate filings, the kind of tedious work that used to require hundreds of hours of human labor and thousands of dollars in database subscriptions. Using an LLM-based method, they achieved the same accuracy in 9 to 40 minutes for under $10. That's not a 10% improvement. That's a 1,000 times improvement in both time and cost. And this isn't just about making existing researchers faster. It's about democratization on a massive scale. The old system excluded people based on geography, funding, institutional access. Now, someone with basic internet access can potentially engage with the entire corpus of human knowledge in ways that were previously impossible. We're expanding the research class exponentially. But here's where things get complicated, and honestly, a little scary. Because this moonshot comes with profound gravitational forces pulling it back to Earth. Let's talk about what I call the illusion of thinking. LLMs are incredibly good at producing what looks like reasoning, but when you dig deeper, some troubling patterns emerge. First, there's hallucination. And this isn't a bug that can be easily fixed. It's baked into the architecture. These models are essentially sophisticated guessing machines, trained to produce plausible-sounding text based on statistical patterns. They don't know what's true in any meaningful sense. They're rewarded for confident answers, even when uncertainty would be more appropriate. Research from Apple found something even more disturbing. When they tested large reasoning models, the ones that appear to show their thinking process, they discovered what they called a complete accuracy collapse as problems became more complex. Even more troubling, the models would sometimes stop trying to think harder, even when they had the capacity to do so. But the really insidious problem is bias and homogenization. Here's the paradox. The tool that appears to enable divergent thinking is actually a homogenizing force. LLMs are trained on the existing corpus of human knowledge, which means they absorb and amplify all of our historic biases. They prioritize mainstream, commonly cited ideas from dominant cultures, primarily English language, Western perspectives. Even models that have been explicitly trained to be unbiased still exhibit pervasive stereotype biases across race, gender, and religion. Why? Because they're fundamentally distribution sampling machines. They can only work with the patterns they've seen, and those patterns reflect centuries of human inequality and bias. Let me share a story that perfectly illustrates the hallucination problem. A colleague of mine, a computational biology professor, was using GPT-4 to help analyze patterns in genomic data. The AI provided a beautifully crafted explanation of how certain gene sequences related to protein folding, complete with citations to what appeared to be legitimate research papers. The analysis was sophisticated, internally consistent, and seemed groundbreaking. There was just one problem. 3 of the 5 papers cited didn't exist. The AI had fabricated not just the citations, but plausible-sounding author names, journal titles, and even realistic page numbers. Worse yet, the fabricated studies were the ones supporting the most novel conclusions. When my colleague tracked down the real papers, they contained no evidence for the AI's central claims. This is what makes LLM hallucinations so insidious. It's not random noise. It's sophisticated, plausible-sounding misinformation that often appears in the most critical parts of the analysis. The AI doesn't hallucinate about basic facts everyone knows. It hallucinates about the cutting-edge stuff where verification is hardest. And here's the truly scary part. We're training a generation of researchers to rely on these tools without developing the deep skepticism necessary to catch these errors. I've seen graduate students submit literature reviews with completely fabricated citations because they trusted the AI's output. The moonshot technology is outpacing our ability to develop the critical thinking skills to use it safely.
To understand the full significance of this moment, we need to step back and look at the bigger picture.
LLMs represent the third stage of what I call the epistemological triad, 3 revolutionary moments in how humanity relates to its own knowledge.
First was Gutenberg's printing press, around 1440. This solved the production problem. Before the printing press, books were painstakingly copied by hand, limiting knowledge to a privileged few. Gutenberg didn't just make books cheaper. By the 1490s, a printed book could cost as little as a month's salary for a schoolteacher. But more importantly, it solved the fidelity crisis. For the first time, scientists across Europe could trust they were looking at identical formulas and data.
Second was the internet in the late 20th century. This solved the access problem. The printing press could only reach as far as human bodies could carry books. The internet connected anyone with a computer to information instantly. But in solving the access problem, it created a new crisis: information overload and the return of fidelity issues. Now we have LLMs, which solve the synthesis problem. For the first time, we have tools that can ingest the entire accessible corpus and provide analysis on top of access. They can cross-reference sources, identify patterns across disciplines, and synthesize findings in ways that were simply impossible before. But now, let's talk about what comes next, because understanding the trajectory of this technology is crucial for anyone who wants to stay relevant in the knowledge economy. We're about to enter what I call the acceleration phase of the research revolution, and there are 3 key developments you need to watch. First, we're moving toward what researchers call multimodal reasoning systems. These aren't just text processors anymore. They're beginning to integrate visual data, mathematical proofs, experimental results, and even real-time sensor data. Imagine an AI that can simultaneously analyze a chemistry paper, interpret the molecular diagrams, cross-reference with patent databases, and suggest novel synthesis pathways based on current materials availability. We're maybe 18 months away from systems that can do this reliably. Second, we're seeing the emergence of what I call recursive research systems. AIs that can design and execute their own research programs. At Google DeepMind, they're already testing systems that can generate hypotheses, design experiments to test them, analyze the results, and then generate new hypotheses based on what they learned. This isn't human-guided research anymore. This is autonomous knowledge creation. Third, and this is the most important trend, we're moving toward networked intelligence, where multiple AI systems collaborate on complex research problems.
Think of it as a distributed research team that never sleeps, never gets tired, and can process information at speeds that make our fastest human researchers look practically stationary.
Now, you might be wondering, what does this mean for specific fields and careers? Because the impact isn't going to be uniform. Some disciplines are about to be completely transformed, while others will see more gradual change. Let's start with the fields that are already being revolutionized. In drug discovery, AI-human partnerships are reducing the time from concept to clinical trial from 10 to 15 years to potentially 2 to 3 years. Companies like DeepMind's isomorphic labs are using AI to predict protein structures and identify drug targets that human researchers would never have considered. We're talking about accelerating the discovery of life-saving medications by a factor of 5. In financial analysis, AI systems are already processing earnings calls, SEC filings, and market sentiment data to identify patterns that escape human analysts. But here's what's fascinating. The most successful hedge funds aren't replacing their human analysts. They're creating human AI teams where the AI handles pattern recognition and the humans focus on strategic thinking and risk assessment. Legal research is undergoing a similar transformation. AI can now analyze decades of case law in minutes, but the real value comes when experienced lawyers use these insights to craft novel legal strategies. The AI finds the needles in the haystack. The lawyer decides which needles are actually useful. But some fields face bigger challenges. Pure mathematics, for example, is experiencing what I call proof anxiety. AI systems like GPT-4 can now solve many undergraduate-level proofs, but they struggle with the kind of creative leaps that define cutting-edge mathematical research. The question isn't whether AI will replace mathematicians, but whether it will change what it means to be a mathematician. And then there's academic research itself. PhD programs haven't fundamentally changed their structure in over a century, but they're about to have to. When an AI can generate a literature review in hours instead of months, what does that mean for doctoral education? We need to completely rethink how we train the next generation of researchers.
So here's where we land, and why I think the moonshot metaphor is both accurate and dangerously incomplete. Yes, LLMs represent a genuine breakthrough that meets all the criteria. They tackle the huge problem of knowledge accessibility, offer a radical solution through democratization, require breakthrough technology, and deliver 1,000 times improvements in speed and cost.
But we can't talk about this transformation without addressing the elephant in the room. What happens to knowledge equity and democratic participation in research? Because this moonshot has the potential to either democratize knowledge like never before, or create new forms of digital inequality that are even more entrenched than what we have now. On the optimistic side, imagine a brilliant researcher in rural Bangladesh who previously couldn't access the latest papers behind paywalls, couldn't attend conferences in expensive cities, and couldn't collaborate with researchers at elite institutions. With AI-powered research tools, geographic and economic barriers start to dissolve. The same AI that helps a Harvard professor analyze complex datasets is available to anyone with internet access. But here's the darker possibility. If only well-funded institutions can afford the most powerful AI research tools, we might see the creation of cognitive castes, tiers of researchers with dramatically different capabilities based purely on their access to technology. Imagine if the top 100 universities have access to AI systems that are 10 times more powerful than what's available to everyone else. The knowledge gap wouldn't just persist, it would accelerate exponentially. There's also the question of intellectual dependency. When we outsource more and more of our thinking to AI systems, what happens to our own cognitive capabilities? Will future researchers retain the ability to do deep, independent thinking? Or will we become cognitively dependent on our artificial partners? It's the difference between using a calculator to do arithmetic faster and forgetting how to do math without one. And finally, there's what I call the truth fragmentation problem. When AI systems can generate convincing-sounding research on any topic, how do we maintain shared standards of evidence and truth? We're already seeing this in politics and social media. Now imagine it happening to scientific research.
The very notion of objective, verifiable knowledge could be at stake.
But the real moonshot isn't the technology itself. It's the creation of what I call researchers' centaurs, human-AI hybrid intelligences that combine the best of both worlds. The LLM alone is unreliable, biased, and prone to hallucination. The human researcher alone remains slow and resource-constrained. But together, that's where the magic happens. So let me give you 3 concrete takeaways for how to think about this technology. But I'm going to make these actionable, not just philosophical. First, embrace the role of critical verifier, but do it systematically. Your job isn't to passively accept AI output, but to become an even more rigorous fact checker and logic tester than you were before. Here's a practical framework. For any AI-generated research insight, ask 3 questions. First, can I independently verify the core factual claims? Second, does the logical chain of reasoning hold up when I examine each step? And third, what would the strongest counter-argument to this conclusion look like? The AI can generate ideas at superhuman speed, but you need to be the filter for truth and feasibility. Develop what I call productive paranoia. Assume the AI is wrong until you prove it's right.
Second, actively fight homogenization through deliberate perspective seeking. Use AI tools to explore perspectives that are minority, non-Western, or paradigm shifting. But you need to be intentional about this. Here's what I mean. When you ask an AI about a research topic, don't just ask for the mainstream view. Follow up with specific prompts like, what would researchers from the Global South say about this? Or how might indigenous knowledge systems approach this problem? Or what are the most credible contrarian views on this topic? Don't let the algorithm's statistical center of gravity pull you toward mainstream thinking. Create what I call bias interrupts, specific techniques to force the system off the beaten path. One technique I use is the perspective rotation method. Take any AI-generated insight and deliberately ask how it would be viewed from 5 different cultural, disciplinary, or ideological perspectives. Your human judgment is what forces the system to explore the edges, not just the center.
Remember that this is augmentation, not automation, and design your workflow accordingly. The goal isn't to replace human researchers, but to elevate human cognitive capability. But here's the key. This requires you to completely rethink how you work. Start by identifying your unique human superpowers. You're better than AI at asking the right questions, understanding context and nuance, making ethical judgments, and connecting insights to human needs and values. The AI is better at processing vast amounts of information, identifying patterns, and generating multiple possibilities rapidly. So, design your research process as a dance between human and AI capabilities. Let the AI handle the heavy lifting of information gathering and pattern recognition, but you drive the strategic direction. Use the AI to expand your thinking, not to do your thinking for you. And here's crucial. Always maintain what I call cognitive sovereignty. Never let the AI make the final judgment calls on what's true, what's important, or what's worth pursuing. Those decisions remain fundamentally human. The new paradigm places an even greater burden on critical thinking, creativity, and wisdom than the old one did. You're not just a researcher anymore. You're a research orchestrator, conducting a symphony between human intuition and artificial intelligence.
Before we wrap up, let me give you some specific next steps you can take starting today, because understanding this revolution intellectually is different from actually participating in it. If you're a student or early career researcher, start building your AI literacy now, but do it strategically. Don't just learn to prompt ChatGPT, learn to use AI as a research partner. Pick a topic you're genuinely curious about and spend an hour experimenting with different AI tools. Try Claude for deep analysis. Use Perplexity for research with citations. Experiment with Notion AI for synthesis. But here's the key. Document your process. Keep a research journal noting what the AI got right, what it got wrong, and what you learned about the collaboration. If you're a mid-career professional, Your advantage is domain expertise. You know your field well enough to spot AI errors that would fool novices. Use this to your advantage. Start integrating AI tools into your existing workflows, but position yourself as the quality control expert. You become more valuable, not less valuable, when you can reliably distinguish between AI insights that are brilliant and AI output that's sophisticated nonsense. And if you're a senior researcher or faculty member, you have a responsibility to help design the future of your field. The institutions that adapt thoughtfully to this technology will thrive. Those that ignore it will become irrelevant. Start conversations about how AI should be integrated into your research programs, your graduate training, your peer review processes. The decisions being made in faculty meetings and department heads' offices over the next 2 years will determine which institutions lead the next phase of human knowledge creation. But regardless of your career stage, remember this. The most important skill you can develop right now isn't technical, it's metacognitive.
Learn to think about your own thinking. Develop awareness of when you're relying too much on AI, when you're not using it enough, and when the human-AI collaboration is producing genuinely new insights versus just sophisticated-sounding recycled ideas.
We're living through a genuine moonshot moment, the third great revolution in how humanity relates to knowledge, following the printing press and the internet. But unlike those previous revolutions, this one demands active, conscious partnership between human and artificial intelligence. The future of research isn't about AI replacing researchers, it's about creating a new kind of researcher entirely, one that's more powerful, more capable, and more responsible than either human or AI could be alone.
That's all for today's Mindcast. If this episode got you thinking, I want to hear about it. Share your thoughts on social media and tag us. And if you're ready to become a researcher centaur yourself, start small. Pick a topic you're curious about and experiment with AI-assisted research. But remember, you're the pilot, not the passenger. Until next time, keep questioning everything.